So we've got an example. 10% of U.S. adults eat fast food 4 to 6 times per week. You randomly select 5 adults. Find the binomial distribution using the chart. Graph the histogram, describe the shape, identify the values that are unusual for the random variable. Find the probability that the number of U.S. adults who eat fast food 4 to 6 times per week is exactly 5, at least 3, and less than 2. So look, guys, this course is kind of changing gears. Most of the problems from now on will be word problems like this. So we need to come up with a way to work word problems. This is the Clark way. First thing I do is I highlight all the numbers. 10%, 4 to 6 times per week. 5 adults. See the 4 to 6 times a week. Exactly 5, at least 3, and then less than 2. Let me fix this. I want that on the other side there. Okay. That'll work. Okay. So the first thing I got to do is I got to figure out what it is that I'm labeling here. So 10% of U.S. adults eat fast food. That sounds like our probability of success. When I see percent, I think probability of success. My probability for success is equal to P. P is 10%. Okay? That's the first thing. Got that down. Now, eat 4 to 6 times per week. All right, we don't really need that number. That's just descriptive, so we can move on from there. You randomly select 5 adults. So that's either N or Q. Well, guess what? N is how many we select, right? That's the total number of trials. We go out, we ask 5 people. So N is equal to 5. P is equal to 10%. Q is 1 minus P, which is 1 minus 0.1, which is 90%. So Q is 90%. Okay? So we've got our MPQ. Now, if I have my MPQ, then I can get my probability distribution from the table. So the first thing I need is N, which is 5. And then I need my X. Well, X is going to be 0, 1, 2, 3, 4, and 5. Those are all the possible values for the random variable. I can have no one that says they eat 4 to 6 times a week, one person that says they eat 4 to 6, all the way up to all 5 people I asked saying, yeah, I eat fast food 4 to 6 times a week. And then I need P equal to 0.10. Okay, so I'm going to draw out my probability distribution. So I need my value of the random variable and then the probability. So 0, 1, 2, 3, 4, and 5. So now I need to go look up in the chart. So let's go to our chart. So let me clear this out real quick. All right, so N is equal to 5. So I go to N, I go down to 5. All right, and my probability is 10. So 10%, so that's this column right here. So these are the numbers that I care about. So at 0, I have 0.59. I have 0.590. At 1, I have 0.328. At 2, I have 0.073. At 3, 0.008. At 4, 000, and 5, 000. Okay, so this is my, excuse me, this is my binomial distribution. Right here, I've got the distribution. So find the binomial distribution. When I see find, that's what I want to do, right? I want to graph the histogram. So I'm going to take this and I'm going to graph it. So if I graph it, what's it look like? My X over here, my probability over here. My biggest probability looks like that's first. At 0, that's 0.590. And then at 1, I've got 0.328. At 2, I have 0.073. At 3, I've got 0.008. At 4, so I'm going to have to move this out a little bit further. At 4 and then 5. And so that's basically 0 for both of those. Okay, so they don't even show up. All right. So what is this? This is skewed to the right. How did I know it was skewed to the right before I ever graphed it? The probability of success was 10%, which is less than 50%, which implies that it's skewed right. Okay, so it's skewed right. So that's my histogram. Okay. Describe the shape. It's skewed right. Identify values that are unusual. Do we have any unusual values? Unusual is 5% or less. Do we have anything that's less than 0.050? Well, it looks like this one, and this one. So 3, 4, and 5 are unusual. Okay? So x equals 3, 4, and 5 are unusual since the probabilities are less than 5%. Okay? Now, what are we asked to do? We're asked to calculate find the probability that the number of U.S. adults who eats fast food 4 to 6 times per week is exactly equal to 5. Okay? Exactly 5 represents the probability x equals 5. So what does that equal to? Well, if I look at x equal to 5, that gets me this right here. So that's just 0.000. Okay? So to 3 decimal places, it's nothing. Now, is it truly nothing? No, it's not truly nothing, but this is using the chart. If you think about it, remember that exactly equal to 5 means that there were 5 successes, right? So that means 0.10 times 0.10 times 0.10 times 0.10 times 0.10. And when I multiply that together, that gets me 0.00001, okay? Which is on 3 decimals is 0, okay? But technically, we're saying there's a chance, all right? So we're technically, there's a chance. All right, so it's really small, but there is a chance. Now, most times you're just going to have to do to 3 decimal places, so you're good to go. Now, what about this scenario? At least 3. At least 3. So at least 3 represents x equal to 3, x equal to 4, and x equal to 5. That's x greater than or equal to 3. The probability x is greater than or equal to 3 is at least 3 here. That's what that means. Okay? So this is the probability that x equals 3 plus the probability that x equals 4 plus the probability that x equals 5. Now, what's the probability x equals 3? I look at my chart. It's 0.008. Probability x equals 4. I look at the chart. 0.000. Probability x equals 5. 0.000. This is the work that I'm looking for if you see a question like this on an exam, people. I want to see all of this written out here. And so that adds up to 0.008. No biggie, right? Now the other example was less than 2. How do I do less than 2? Less than 2. What x values are less than 2? Is 2 less than 2? No, I don't think so. 2 equals 2. So 1 works, but also 0. 0 is less than 2. So this is the probability that x is less than 2, which equals the probability that x equals 1 plus the probability that x equals 0. And so the probability that x equals 1 from our chart, x equal to 1 is 0.328. Plus the probability that x equals 0 is 0.590. And when I add those together, I get 0.918. So how do I interpret this? Well, the probability that the number of U.S. adults who eat 4 to 6 times per week is less than 2 is about 92%, 91.8%. Right? So that's how you would interpret that. So use the chart when you can. To use the chart, you need to know your n first, then pick out your x, and from there, you look at your p-value, your probability of success, that tells you the column, and then you figure it out, okay? And 3 decimals should be good enough. The problem comes whenever you've got a probability that's like 0.32. If you look at this, you have 30 and then 35, so there's no 32. So if that's the case, then you have to use the formula. Okay, the formula, the p of x equals the n factorial over n minus x factorial p to the x times q to the m minus x. And there you would put the p of the 0.32 raised to the x, and then the 1 minus 0.32, which I guess would be 6.8, to the n minus x. Okay? So that's where you'd have to run in and use the formula. And I think there's a way to do it on your calculator. I'm not sure mine's smart enough to do it, but if you go into, let's see, let's just try going into stats. So when you go into stats, I think, let me instead of doing stats, do second vars. And when you go into that, I think that's where you can do it. So let me do second var, and that gives you the distribution. And so then you would go to the binomial PDF, which I can't do, okay? But second distribution, which is that vars button, and that will, if you look, you'll see the binomial PDF, which is A on this calculator, but it's BINO and then PDF, and then you can type it in. Okay? So maybe, well, you know what? I wonder if I could pull out a video, see what that does. Okay. So let's see if we can do this. So got our calculator. All right, can you see that okay? All right. So if I do second distribution, I can scroll down and I see binomial PDF and I hit enter. Okay, so let's see if this works. So let's do n equal to 5, and then I'm going to do a comma. I don't know if this will work or not. I haven't done this. I wonder what else I need. I guess I need a x value. I think I wonder if it's an x value next. We'll see here in just a second. So let's try x value of 1 and then a comma, and let's do a probability of the 0.1, and then let's close it and see what happens. Okay, so that didn't work. So I wonder if it's the probability. Let's try this. So let's do 5, then comma 0.1, and then comma 1, and see what that does. All right, cool. So yeah, so this works, okay? So when you do the binomial PDF, what you're gonna do is you're gonna have the first thing is your n, then you put a comma, and you put the probability p, and then you put a comma and how many successes x there are. And then your calculator will get that out for you. So if you were trying to do something weird, like so do second distribution, go down to binomial PDF. And if it was like, I don't know, 10 trials, but your probability of success was weird. It was like 0.32, right? It's not in the chart. And you wanted to know, well, what's the probability that you get like 4 successes? Close it up. And then that would give you the probability there. Okay, so it's a quick way to get the answer without having to use that complicated formula. All right, guys, hope that this video was helpful.